Hello and welcome to our presentation of the DataLEASH project. DataLEASH stands for Learning and Sharing Under Privacy Constraints, and our team is affiliated with KTH, Stockholm's University, and RISE. And you see the pictures below. So what is a problem that we're trying to solve in the DataLEASH project? Quite simply put, it's that the privacy risk has increased over the last years and with more digitalization. So we have some developments that contribute to this. More data is being collected, and we have had advances in machine learning, computational resources have become cheaper and more efficient. And we also have more accurate and detailed data. So not just more data, but better data. There is also an increased pressure to share data and to share machine learning models and do automation. We get a lot of benefit from using machine learning for data analysis, but it comes with a few risks. So one of the risks is that someone could be able to link a particular record to an individual, even if the record in a database has been anonymized or pseudonymized or de-identified. Then machine learning models may retain information about the data that they have been trained on. So even if one does not share the data itself, machine learning models may be able to lead to other kinds of unwanted inferences, such as whether an individual's data was included in the training dataset. And if one knows what the dataset is about, one can infer that the individual also has the property associated with the database. So we want to reconcile this. We want to take advantage of the value that we get, the utility that we get from data analysis, but also preserve the privacy. So the research objective of the DataLEASH project is to come up with tools and methods that provide us with provable guarantees for privacy and still provide the utility of the data analysis, and all that in an adversarial setting where we assume that there is some attacker that tries to find out as much as possible and infer things that people did not disclose voluntarily. So we want to have these privacy guarantees and utility, both in terms of theoretical results and applying them to concrete scenarios. We're taking a multidisciplinary approach. So, for example, at Stockholm University, we have people from health informatics and also the Health Bank, which is a collection of health data from the Stockholm region, and also from the Institute of Legal Informatics at Stockholm University. And at KTH, we have a combination of disciplines such as privacy-enhancing technology, computer science, cryptography, statistical inference, and information theory. And from RISE, we have a team working from a machine learning and AI perspective. And we now highlight just a few of the aspects of our work. One aspect of the multidisciplinary approach is that we can try to bridge the gap between law and technology. We often use terms and concepts quite differently depending on our discipline. And one such notion is that of data minimization. And here we relate the legal principle to a mathematical concept. So let's look at the principle of data minimization as an example. What it means informally is that we only use as much data as is needed to complete a particular task. And more formally, we define a sufficient statistic as a data transformation that is equally good for the statistical inference task. So the utility is equally good. And the transformation can be non-reversible. So we can lose some information in the transformation. And thus the principle of data minimization requests a sufficient statistic which cannot be transformed more with non-reversible transformation without losing utility. So we said we wanted to have provable privacy guarantees. And those require that we have an analytical measure that also has operational meaning, and in this case for risk assessment. And we developed such a measure that we call pointwise maximal leakage, and that is actually robust against kind of adversarial statistical inference. We've talked about the privacy risks from using machine learning for data analysis, but can we turn it around and use AI or machine learning for privacy? And here are some approaches that do just that. In the lower right corner, we see the process of data learning and sharing. So we collect the data, we can transform it, and then we analyze it, and then we share it, or share the results, or share the data. And this gives us a set of intervention points where we can actually do something to preserve the privacy. And here we're using machine learning in the phase between collecting the data and analyzing the data. And we do that by creating synthetic data. So this is motivated by the observation that synthetic data is, just fake data and can thus not be directly linked to individuals. But if we're not careful in the way we are generating synthetic data, then our utility may decrease because the data is less accurate, or we have a risk of membership inference. So one could maybe still infer whether one's data were included in the data used for generating a model for analysis. And we can do this for different data types. Structured data like census data or health, patient data, patient records. And here I'm showing one example for image data. Given a set of facial images, we want to analyze the data set without exposing any individual identity. The way we go about this is to create synthetic faces from a set of the original data faces, and this synthetic face then represents a whole cluster of faces, and we can tune the size of this cluster to give us different values of what is called k-anonymity, which means that one is indistinguishable from others in a set of k people. And what this also allows us to do is to find any good spots in the trade-off between privacy and utility, to find any places where there's no linear relation, and we can maybe get a lot of privacy gain by a small loss of utility, or the other way around, we can get a lot more utility by sacrificing just a little on the privacy guarantee. So we did this using generative adversarial networks to get the synthesized faces and created a whole workflow to find this good trade-off and get privacy guarantees, in this case in the form of k-anonymity, at minimal loss of utility. Another example where we're using machine learning and AI to help with privacy is that, in contrast to the previous example where we wanted to hide the whole identity, here we just want to hide a particular attribute. And in this case, for example, we can hide whether the facial expression is a smile and replace it with a neutral expression. You can think of it as hiding an emotion from surveillance cameras, for example. Another example where we use machine learning for privacy is transforming textual patient data and de-identifying it using BERT, which is a shareable language model to enable automation of tasks and analysis of health data without privacy leaks. And this model was pre-trained on de-identified clinical text and data from the Royal Library. And this model has been approved for sharing to academic users, and it has been applied to different datasets of patients' records in different hospitals and found to perform really well. Getting back to law and informatics and the interdisciplinary view, here are some of the core questions that we address in the DataLEASH project. What is privacy, or what is applied privacy in terms of personal data processing individually and for society? And then also the broader notion of integrity, the governing processes in jurisdiction, the professional roles of controlling or processing the data, and the data subjects whose data is being processed, and consultants, and knowledge management. How can we have the legal definitions fit with the technical concepts, and what are the implications for risk-based approach? Now, this is digitalized in Stockholm. Sweden has been at the forefront of privacy in terms of regulation, not just of privacy, but also of transparency in the form of the principle of openness. And what contributed early on was, well, the limited number of inhabitants, but also the high awareness of technology and the high degree of digitalization for the time. Datainspektionen, which is now called IMY, the Swedish Authority for Data Protection, was also recently tasked with educating the society on AI and privacy. And we have contributed to this. We were invited to workshops organized by IMI to present research on privacy and AI to a variety of stakeholders. So DataLeash fits well into this tradition, bridging technology and law and contributing to research and public awareness.